We developed a low-power IoT smart outlet for the course Low-Power Embedded Design Techniques. It was a team project. We are a team of 2 and it took 6 months for us to develop the entire product. Our product is to develop a more connected home for reliable and sustainable housing, and we wanted to make it much more energy efficient so it's more greener, and we wanted to develop a mobile app so anyone can control and configure the device. And the entire project is funded by Building Brains and University of Colorado Boulder. Why Thread? It's a very new protocol being adopted by the industry, and it has a lot of security features inbuilt, and it's a 6-LoWPAN based protocol, and it's a stack on top of Zigbee, which means it's much more reliable, and it supports mesh networking, and it supports UDP, so which makes it unique, and it's easy to develop anything on top of UDP, and it's a IPv6 based protocol. This is the complete block diagram of our project, and the system has 2 entities. One is on the cloud side. The cloud side, all these services are done in Amazon Web Service, and we have a Wi-Fi router, and then we have mobile phone controller, that's on the cloud side, and we have another entity that's in the house. In the house we have 3 different things. One is the central hub. The central hub talks to the internet and the rest of the devices in the house, and we have a server. The server is the one which actually talks to the devices. The server talks to the other devices using Thread protocol, and the server and the central hub is communicating using UART. And in the entire course we actually developed the hardware, the end devices, and we programmed the Silicon Labs dev kit as a server, and we have a Raspberry Pi for the central hub. And let's look at the end devices in detail. This is the modular circuit and a block diagram of our end device, and we have a PMU unit which takes the supply, AC supply, and which gives a 3.3 volt output, and we have a relay actuating circuit as well, to actuate any load which is connected to the device. And we have a couple of sensors, temperature and humidity, just to take data on the house, on the outlet, where the outlet is located. This is the prototype that we actually built. You can see the outlets, and we have a transformer. This is the biggest and bulkiest part in our project, and this is the backup circuitry. The backup circuitry is nothing but if we don't have AC power, we can still be able to talk to the device and get the sensor data out of it. And this is the thread module we have. This is the reset circuitry, and this is the relay actuating circuit. Let's have a look at our demo. We have 3 things in the actual hardware. We have a hub which is connected to the internet and which can talk to the server. The server here, I mean, it's a thread server, and this thread server can talk to the client. There are 2 clients here, and outlet client 1 and outlet client 2, and the outlet client 1 is connected to the load, and outlet 2 is not connected to anything, but we're gonna read temperature and humidity from these sensors. Let's look at the app. We have 3 options in the app. The first thing we have to do is configure the Pi. So in configuring the Pi, we have to give the IP address and its port number to configure the Pi, because this mobile phone is connected to the server and the server is connected to the Pi. So I did that already, and we can add devices, which I have done already just to speed up the demo process, and we can use the device. I have 2 devices here, and let's choose device 2. That's where the load is connected, and let's turn on the relay. You can see the load is getting turned on, and you can see the feedback from the server. And if you want to turn it off, yeah, it's turned off, and I can read the temperature, and I can read the humidity. Yes, I can go back to device 1 and I can do the same thing. Yes, yeah, that's it.